From the last two examples, you may have got an impression that tags are mainly a feature for the UI, mainly a cosmetic feature that users can use to organize their work and find the information they are looking for. And that's certainly not incorrect, but there's also a deeper meaning to tags in the world of Metaflow. And that's intimately related to the concept of namespaces. So how namespaces work in Metaflow is that, as you have seen, every run gets some ID. So for instance, we may have a flow called prediction flow. When we execute it, we get prediction flow 3. We keep executing it, so we get another ID, prediction flow 8, prediction flow 34, and so forth. And now imagine that there are multiple data scientists working together. So maybe Anne is executing this set of runs, Will is executing another set of runs, and they can work concurrently, and like everybody kind of gets their own executions. Now, what is significant is that Metaflow automatically assigns a tag to every execution that corresponds to the username. So when user Anne executes flows, they are automatically tagged with the username user Anne. All these things here, all the pink ones here. And when Will makes his executions, all those executions get the tag called user Will. And actually these are called system tags, and you can't change them afterwards, because the idea is that, well, I mean, the fact that they were executed by Will, that simply doesn't change. Now, what namespace simply means is that namespace is a collection of runs that have the same tag. So for instance, we can say that there's a namespace user Will, that is the collection of all runs that have a tag user Will. And maybe another way of thinking about it is that those are all runs that were executed by Will, and the same thing for Anne. Now, since these user namespaces are nothing special, they are just tags as anything else, you can also have namespaces based on your own tags. They don't have to be based only on the user. So for instance, imagine that you assign a tag called XYZ features to a certain run, like let's say feature flow 34 here, and like you assign the same tag to another execution here. You can say that now there's a new namespace called XYZ features containing these two runs, and they might be even executed by two different people in this case, but now in the sense of XYZ features, they form the same namespace. And now you may wonder that, okay, what's the point of all this? I mean, why does it matter? Well, I mean, mainly it matters in this like one context. When you're using a client API to have these relative references that you don't refer to a specific run like by its ID, but you say that give me the latest run. There is this question that latest run in the context of what? Is it the latest run like that anybody ran anywhere in the world, or like is it the latest run that I ran, or like is it some other latest run? And simply the answer to that question, that it is the latest run in this namespace. So if you don't define any namespace, we assume that you refer to your own stuff. So if Will just says latest run, I mean, it would be 28. If Anne says latest run, it would be 34. But if they say that namespace is explicitly XYZ features, now in this case, the latest run is 34. Okay, so let's see how it works in practice. So in this case, we have split our existing example in two parts. So now we have this data pre-processing part in a flow of its own called tree features. I mean, it's the same code. It's just like in a flow of its own. And then the model training part is in a separate flow called tree training. The same code, again, just in a different flow. Well, why you might do this? Well, there are a couple of reasons. One is that in real life, these feature engineering pipelines might turn out to be quite complex and long, so it might be just convenient to have them as a separate entity. It might be that this is developed by a different person, in which case it is certainly convenient that like you have separate files, just makes the code hygiene and like Git hygiene easier to handle. Or it might be that maybe you want to, let's say, like run the flow more often. Maybe you want to produce the features every day, and maybe only like retrain the model every week or something of that sort. So like whenever you have a different cadences like that, you need different flows. Okay. Well, now the key part is that let's start by executing the code here. So when we do feature flow run, this code runs, and like while that's running, I will show you something here. So now the way how the training code retrieves the result from the feature run is that it says that, okay, give me the latest successful run of the three features. And as we just discussed, the latest successful run refers to a certain namespace. So let's see how it works. let's run the training run here. So now we can see that the namespace in this case, since I didn't mention anything specific, it's called like Ville demo, which is the username that I have here. And we can see that actually the run ID refers to the 448, which is the one that we just executed here. And now the model is being trained here. Well, now imagine a situation where, let's say you have two data scientists working together. It might be that let's say Anne is working now on the feature flow. It might be that now she has some ideas how to improve the features. Let's say like she wants to drop a feature. There's years at company. And now we can execute the code. And now imagine Will is the one working on the modeling part. Well, now when Will executes the code, presumably he will get different results. So previously the accuracy was, let's say, 81. Now when Will runs the code, he will most likely get different results. Okay, now we can see that it is now getting the 455 features, which is the new set of features that Anne produced. And indeed, the accuracy is different. It is actually higher in this case. But now imagine a situation where Will is iterating on the model by himself, and now if you kind of have this moving foundation, it's really hard to track consistently like which improvements are due to the improvements in the model and like which are maybe improvements in the data that also keeps changing. So it would be a better idea to kind of like fix the foundation and say that I always want the same set of results until I decide something else. And how we can do that is that we can say like for the feature flow that now we add a tag, and like we add a tag, let's say like for the initial execution that we had here, I guess it was this one here. Let's take that ID and let's call this latest features. Right, and now we can actually see that like we have the user tag there, but we also have the latest feature tag. And this might be also evident if we look at the UI here. We can see that our original execution is now tagged as latest features, and then the kind of the second one we did, it doesn't have any tag. And now when we go back here, and let's say now Will wants to have that solid foundation, what he can do is that he can say that, okay, I want to run this in the namespace of latest features. And now in this case, like we should see that it is using exactly like the features like from that run ID, which is the first run ID that we executed. And now what we should also see that the accuracy is exactly the same as before, which is exactly what we want. So now you can imagine that Will can keep iterating on his modeling part, knowing that like at least the data absolutely won't change. Like he can be sure that like the kind of like he will be always getting results like from that particular snapshot of data. Now, meanwhile, you can imagine that now Anne like looks at the feature engineering code, like realizes that, for instance, here they totally forgot to add the categorical features. So now she executes the flow like with the fixed features. And then maybe at the same time again, Will executes the code, but still like referring to the latest features. But now the important fact here is that the fact that Anne is iterating on her part like really doesn't affect Will. I mean, Will has kind of a bubble of his own like where he can operate. And now only like when, let's say, Anne decides, maybe she goes to Will and says that, oh, by the way, I realized that the kind of now there's a way better set of features and like you should be using them. Like what they can do is that they can now say that they want to not necessarily move the tag, but like add another tag now for the kind of the latest iteration of features. So now we have the situation that looks like this, that like we have a new set of latest features. And now what happens when, as you can imagine, like when Will executes the code, now the latest features is indeed pointing at the latest set of features that Anne produced. And now we totally expect to get the different results. And in this case, yes, indeed, the results are better than way before. So for those of you who have used the tagging feature in Git version control system, this feature like may seem immediately familiar. So Git uses tagging exactly for the same purpose, that you have immutable commits in the same way as we have immutable run IDs in Metaflow. And then you can move tags between these commits. And like you can kind of have that like a layer of mutable interpretation on top of the commits that are mutable. And in the same way, you can kind of use tags as just like a pointer feature, like through namespaces, that allow you to kind of fix a certain baseline, certain foundation, like when you need a fixed foundation. And then like when you think that the time is right, like you can kind of move that pointer, like move that foundation and like update everything downstream.